These 15 glowing entities powering up represent a fully autonomous production suite. They are synthetic employees, operating in tandem to execute complex logic. This system currently automates over $11.1 million in annual labor. That valuation is based on an audit of market salaries for the 15 specialized roles, from senior developers to creative directors, that these agents perform autonomously. The constraints behind this build are absolute. This entire suite was engineered by a single developer. There is zero venture capital backing it, and the system runs on exactly zero recurring API hosting costs. Reaching this scale requires moving past manual syntax generation and the traditional ways we build software. The precise architecture making this synthetic workforce possible is open-sourced through a framework called the DDS Vibe Academy. This animated diagram illustrates how the curriculum abandons linear tutorials. Instead, it maps the required skills across a 25-node constellation. The structure pushes you through 4 distinct orbital rings: foundation, development, application, and mastery. Progressing through these specific nodes forces a professional shift. You stop acting as a bricklayer writing individual lines of code and start operating as a system architect. The entry points are flexible. Bypass the basic definitions and drop straight into your level. Navigating this exact map is how you scale an AI into a sovereign, enterprise-grade workforce. The core operational philosophy driving this system is intent-based engineering. It requires a structural shift away from manual coding. This schematic blueprint outlines the intent-based framework. Your role is strictly to define system constraints. You direct the master node and hold specialized AI sub-agents accountable for the actual implementation. Compare this to the standard method of single-prompt AI interactions. When an engineer asks a chatbot to write a script and simply hopes for a complete result, the logic breaks down at scale. The mechanics of managing autonomous agents are mastered inside the development ring of the constellation map. Specifically, the Claude Code Masterclass serves as the foundational curriculum for composing agents capable of doing the work you used to hire people for. Without an intent-based architecture, AI outputs will plateau at generating basic scripts instead of sustaining reliable production systems. To execute intent-based engineering in a live production environment, you have to adhere to 5 rigid pillars. This animated diagram outlines the framework. Pillar 1, Constraint-First Design, defines strict boundaries. Pillar 2, Progressive Disclosure, prevents confusion by controlling context sequence. Pillar 3, Deterministic Rails, lock the AI into rigid pathways. Pillar 4, Context Hygiene, purges irrelevant data for speed. Finally, Pillar 5, Sovereign Fallback, ensures survival disconnected from the cloud. Adhering strictly to these 5 pillars is the difference between building an unreliable AI toy and deploying a resilient, automated enterprise asset. A true enterprise stack never relies on a single, massive large language model. It uses a composite of specialized models. This diagram shows multi-model routing in action. A central hub instantly sorts data requests to optimize speed. Visual logic tasks route to Google Gemini image models. Complex video processing pushes to VO 3.1. Deep reasoning and coding tasks route to Claude. The practical application of this theory is documented in the Atelier OS case study, located in the application ring of the curriculum. Through this exact routing architecture, we successfully orchestrated a 1.5 million parameter multi-agent system in just 52 hours. Proper model routing bypasses the bottleneck of relying on a single system. You create a customized, composite super agent. There is an economic flaw in cloud-depending AI systems. If you scale autonomous usage, you scale API costs directly into bankruptcy. This physical hardware points to the outer mastery ring of the constellation, which focuses entirely on the Ollama sovereign stack. Local inference frameworks allow engineers to run models with hundreds of billions of parameters directly on hardware they own. This architecture provides 2 distinct benefits: absolute data privacy and the complete elimination of recurring cloud API bills. True technological independence requires owning the infrastructure, not renting it from enterprise cloud providers. The entire DDS Vibe Academy, all 25 nodes, the prompt libraries, and the architecture maps, is completely open-sourced and ungated. This image of an organic cotton hoodie wrapped in data streams represents the actual funding model. The Academy is completely subsidized by the physical commerce of the Design Delight Studio storefront. This sustainable model exists in direct opposition to the restrictive paywalls you see in standard enterprise coding bootcamps. Gatekeeping architectural knowledge is a systemic flaw in the software industry, and this project is actively dismantling it. The shift over the next decade is clear. The software industry belongs to system architects, not fast typists. Watch how these data nodes expand. That represents the $11.1 million in automated labor achievable when these methodologies are correctly applied at scale. Enter the constellation map and start your architectural journey at the exact node that matches your current competency. The tools are open, the map is free. The capacity to scale is now a matter of architecture, not headcount.